Okay, sorry about that, guys. I did not even see the timer running out. So let's just try and do one more example, and then we'll take a break. Or, oh, I forgot to pin this.
Say your audio muted.
Thank you. Okay, I was talking. But let me just try my best to tell you what I was talking about. So I was just going to say, I was just saying before when I was muted, I was saying that let's just try and do this one example and then take a break. I hope that's okay. Okay, so, and we have to compute the order of this element 5 and Z mod 27 cross. Okay, that means we need to compute 5 cubed, 5 squared, 5 to the 6th, and 5 to the 9th. If any of those are the identity, then that will tell us what the order is. If none of them are, we know 5 to the 18th is 1, so the 18 will be the order. Okay. So we just compute 5 squared, that's 25. That's not 1, mod 27. Okay, what about 5 cubed? 5 cubed, that's 25 times 5. Well, we can write 25 as -2. So it's -10. Another way to think of that is mod is 17. That's not 1. So we know that the order is 6, 9, or 18 now. Okay. What about 6? Well, we can write that as, so 5 squared is 25. So 5 to the 6th is 25 cubed. That's -2 cubed. That's just -8. Another way to write -8 is 19. That's mod 27. So that's not 1. So 5 to the 9th, that's gonna either be that's gonna be 1. And if it's not 1, then we know the order is 18. So what is 5 to the 9th? Well, we can write it as, it's just 17. 5 cubed times 5 to the 6th. Okay. I guess that's like 18 squared minus 1. Right, now mod 27, 18 squared will be 0, so this will just be -1. right? Because 18 squared has a 9 factor of a 9 squared, and 9 squared is divisible by 27. Okay, so 5 to the 9th is -1, it's not 1. So this lets us conclude, so the order of 5 is 18. Because we just showed that the order of 5 was not 1, 2, 3, 6, or 9. So the only remaining possibility is 18. Okay, let's do one. Oh, there's a question. Oh, no. Okay, no, I said I would take a break after this. So let us just take a 5-minute break. When we come back from the break, we'll just do a few more similar examples just to be safe. Okay, so yes, just let's get up and stretch our legs for 5 minutes. I'm gonna just leave this on. I guess maybe I should stop recording or pause. So I'll pause and then, yeah, okay. Okay, let's start again. So let's do another example. Let's try and find the order of 10. Okay. Again. Okay, so we just need, so 10 is not congruent to 1 mod 27. So we just have to compute 10 squared, 10 cubed, 10 to the 6th, 10 to the 9th. If one of those, one or more, is the identity, then that will tell us what the order is. None of those are the identity, then the order has to be 18. Okay, so let's just compute 10 squared is 100. Mod 27, 3 times 27 is 81. So that's 19. What's 10 cubed? Well, that's just 10 times 19. It's 190. What's a multiple of 27? Like, that's close by. I guess we do some scratch work and try and divide 27 into 190. It goes in how many times? Like 7 times. And we have a remainder of 1. So 10 cubed is actually congruent to 1 mod 27. So now we stop. The order of 10 is 3. Okay. Okay, now for the question on the assignment, we have to know. For the assignment, we have to remember what is phi of 36. That is, so 36 is like 9 times 4, so it's 3 squared times 2 squared. So that's just 5, 3 squared times 5, 2 squared. That's just 3 times 3 minus 1 times 2 times 2 minus 1. That is 3 times 2 times 2 times 1. That is 12. So phi of 36 is 12. We just have to know the divisors of 12. The divisors of 12 are 1, 2, 3, 4, 6, and 12. So on the assignment, we just have to check, whichever element we have to check it, that element to the first power, second power, third power, fourth power, sixth power. If none of those give you the identity, then you can conclude that the order is 12. Well, if one of those is the identity, that's the order. So that's the other thing you can do. Okay. The other part of the question is just to look at the kind of similar set of elements, but as a group under addition. So let's do like one example of that. Because that is usually a little bit simpler. Okay. So another example. Let's find, this is, now we're working in, let's just work in Z mod 36Z under addition. The order of something like, let's find the order of, let's say 14 or something. Let's find the order of 8. Let's find the order of 7, just as examples. Okay. Okay, so we need to solve n times 14 is congruent to 0 mod 36. If we rewrite this, this means we need to solve n times 14 equals 36 times k for some integer k. Okay. And we're solving for n, and k can be whatever. Okay. Now, what does that mean? We need to solve n times 7 times 2 is 3 squared times 2 squared times k. Now, when we solve this question, of course, we can cancel off a 2 from both sides. So now we need to solve n times 7 equals 3 squared times 2 times k. Now, it is, therefore, it must be that, like, if we use, if we factor both sides into primes, we need to have a 7 on the right. We need to have 3 squared and a 2 on the left. Okay. By prime factorization, three squared times 2 must divide n. Now, if it also happens that, so 3 squared times 2, that's 18. If it also happens that 18 times 14 is congruent to 0 mod 36, that would be the order. Now check. Notice that 18 times 14, that's just 36 times 7, which is 0 mod 36. Okay. So what that tells us is that, so this statement tells us that the order of 14 is less than or equal to 18. This statement tells us that the order of 14 is at least 18. And so the order of 14, this must be exactly 18. Okay, and why is it 18? Well, 14 and 36 had a common factor of 2. Once you factor out that common factor, yeah, that kind of reduces the possible order by 2, and it had no further common factors, so it gives 18, I guess. Okay, let's try it again. For 8, which is in Z mod 36Z, we want to solve n times 8 congruent to 0 mod 36. In other words, we want to solve n times 8 equals 9 times 2 equals 36 times k. Now, if we factor out a 4 from both sides, we have 2 times n times 2 equals 9k. Where n is going to be the order of 8. And since we've canceled all the common factors on both sides, since 9 doesn't occur in the factorization of 2, it has to occur in the factorization of n, sorry. So that means 9 divides n. Okay, now if you check, 9 times 8 is 72, which is a multiple of 36. So that means that the order of 8 is at most 9, and this tells us it's at least 9, so it's exactly 9. So now we check that 9 times 8 equals 72, which is 0 mod 36. So that tells us that the order of 8 is exactly 9. Okay. So yeah, so did anyone want to go over anything that we were just talking about or anything on the assignment? Now would be a good time for that. Okay, so is it, someone asked me, is it okay to do a different method? Yeah, for this, use whatever method you like best. It's fine. Okay, so I will move on to talking about the symmetric group for a little bit, but if anyone wants to circle back to questions on the assignment, we still have time to do that, like after the next break. So if you think you want to circle back to the assignment, don't be afraid to ask about that. Okay. Actually, so I keep on track with time. I see that I just have 10 minutes left in this session. So let me just remind you of a few things and then we'll take another quick break and that'll be the last break. Okay, so let me remind you. So what is SN? Those are just the set of all permutations on the set 1 to up to n. Okay. If sigma is in Sn, then sigma has a cycle decomposition. And sigma can be written as a product of transpositions, but the transpositions are not unique or not disjoint, and this is the way of writing it as a product is not unique. And so T1 up T2 up to Tn are transpositions. And what we would say is that the parity of n is independent of the choice of T1 up to Tn. And finding the transpositions to write sigma as a product of transpositions is essentially like a game or a puzzle if you want. I mean, you know, I guess there is an algorithm, but I just find it easier to think about it like it's just a puzzle, and then if you do it a few times, you'll get the hang of it. So anyways. Okay, so and then once we have this idea that whether n is even or odd is independent of the choice of these transpositions. So let me remind you that each transposition is just like just a two cycle. T1 is like A1, B1. T2 is just like A2, B2. Right. And it just says, what this says is that if you want to like rearrange these numbers in some way, you can rearrange them just by switching two at a time. And if you think about it that way, it's actually obvious that you should be able to do this. Because that is probably the way you would do it anyways, is by switching two at a time. I mean, that's how I might do it anyways, you know. Okay. Okay, and then the last thing I want to say before we take a break is that we can define this the sign SGN of sigma to just be -1 to the n. So the sign of sigma is 1 if n is even, and the sign of sigma is -1 if n is odd. So, and then we say if n is odd, sigma is an odd permutation. If n is even, then we call sigma an even permutation. Okay. Okay, now let us take another 5-minute break. And then we'll see what we want to do then. Okay, so I will start the meeting back up in 5 minutes. Okay.